Okay, so this is question 12 in chapter 25. So, an incandescent light bulb uses a coiled filament of tungsten that is oopsies. Okay, let me fix that. So, length equals 580 millimeters. Diameter equals 46 micrometers. At 20 degrees Celsius, which is going to be the low temperature. The current is 0, and the resistivity is 5.25 E negative 8 ohms times meters. When the temperature is 20 degrees, which is the high, TH, the current is going to be 1 amp. Okay, and I think, yes, that's all the information that we're given. So, for part A, what you're going to want to do is your resistivity or resistance equation is R equals, rho times length over area. So this is really easy, you just plug it in. So R equals, and it's asking at 20 degrees. So yeah, you can just use this. 5.25 E negative 8 times the length, which is 580 millimeters, which is 0.58 meters, over the area. And the area is equal to, what is it? I think it's just pi r squared. So the diameter is 46, so it's going to be pi times diameter over 2 squared. So it's going to be pi times 46 E negative 6 divided by 2 squared. So pi 46 E negative 6 over 2 squared. So you literally just plug all that in. Let me do that on my calculator really quick. And I get 5.25 E times negative 8 times, 0.58 times pi times 46 over 2 squared. And I get 18.3 ohms at 20 degrees. So that's my answer for part A. Now part B is a little more crazy. So you're told that, so it's giving you the potential difference is 120 volts. And it tells you that, in the question, it tells you that the temperature of the filament increases linearly with current. So, also I forgot to write up here, you're also given alpha. So let me move some stuff around. So alpha equals 0.0045. Okay, and that's important later. So so you're supposed to find the equation that relates the temperature as a function of current. Okay. So since it's linear, you can do this like thing here. So T minus TL over I minus IL equals TH minus TL over IH minus IL. And that's because that's like the thing where you'd approximate where you'd find like a linear equation with 2 points. or something. I don't really know. I got this out of Chegg, so this is kind of like foggy for me. So just accept it. I don't know. So t minus 20 is over I minus 0 equals the high temperature is this, minus 20 is the low temperature. I minus I sub h minus I. So t minus 20 over I equals 250 over this is supposed to be a 0. Minus 0. Oh yeah, and this is 1 because I at the high temperature is 1 amp. Okay. So then you just solve for t and you get 250 or 2500 I plus 20. Then you use your this thingy equation. I don't know. I plus alpha t minus t naught. And v is IR. Okay. So yeah, okay, so since you're given the potential, you want to make sure you can use this equation and this equation. So you can just do that by multiplying this by I to set it equal. So V equals R naught. Let me do that the other way. So I times R naught, I plus alpha T minus T naught. And T naught is going to be the low temperature because that's the initial. So I'm just going to go ahead and write L. Okay. So, okay, and I'm also dumb because this is supposed to be a 1. I'm sorry. Golly, I need to memorize these equations. So V equals I R naught times 1 plus alpha times oh yeah, okay, so yeah, you solved for t down here. So go ahead and highlight that. T. Okay. So that's gonna be 250 t minus or plus 20 minus 20 there. Okay, highlight this so it's obvious. This video is probably going to be really long, so I might not even be able to send it. Oh well. Okay, so you're given that V is 120, so 120 equals I times R naught, which is your resistance at 20. So this is equal to R naught. Highlight this in another color. Let's see. So you're given 18.3 times plus 0.0045 times 250,000 T. Okay. Okay, now 120 equals I times 18.3 times 1 plus 11.25 I. Shoot. Okay, that's, golly, wow, I'm really, this is probably a very confusing video. I might just take a screenshot of this and send it. Golly, this is really bad. Okay, well, anyways, 120 divided by 18.3 equals I plus 11.25 I squared, because you just multiply that out. Then you get 11.25 I squared plus I minus 6.56 equals 0.
And guess what? That's a quadratic equation. And you get to use the quadratic formula. Yippee!
So, I equals -1 plus or minus the square root of 1 minus 4, 11.25, -6.56 divided by 2 times 11.25.
Yippee!
Okay, and then I didn't do the work, I just looked at the answer. So I equals about 0.72 amps. And you get two roots or whatever solutions, but one of them's negative, so you can throw that one out the door. Okay, so that's part B. Yay. Okay. Then the next part is part C. And so part C is asking you for the resistance when the potential is 120 volts. And guess what? You can just use, actually, that's such an easy part that I'm just going to keep it on the other page. So, move that sucker over a little bit. Okay, so part C is going to be, so V equals I times R, R equals V over I. You're given it's 120 volts, and you just found that it's 0.72 amps, so 0.72 divided by 120. Oh, sorry, I'm really bad at this. 120 divided by 0.72, and you get R equals 167 ohms. Oh, man. Two more parts. Okay. Then I'm going to highlight this because this is an important equation. And then I'm going to highlight this too because I didn't earlier and I feel bad. I don't want to leave anybody out, And then I'm going to make sure that you know that this is where that comes from. And then, so D is also kind of easy. It's just the energy equals VI times T. And that's another equation that I guess you have to know that, he didn't talk about in lecture, which is fine because it's just common knowledge, I guess, right? So that's going to be 120 volts times 0.72 amps times T, which is 1 minute, and that's 60 seconds. So that's 5.184 joules, but it asks for kilojoules, so you do 5.18 kilojoules.
Yippee!
Okay, and then, so one more part, and it's also kind of hard because, you have to do another quadratic equation. So this time the voltage is 60, so 60 equals, you go back to your equation like here. This is where I'm going to start. So 60 equals 18.3 I times 1 plus 11.25 I. And then 60 divided by 18.3 is 3.28, so it's going to be 11.25 I squared plus I minus 3.28 equals 0. And you get to use another quadratic thing. I don't remember what it's called, I'm sorry. yeah, so
Excuse me.
I equals -1 plus or minus the square root of 1 minus 4, 11.25 minus 3.28 divided by 2 times 11.25. And then you just work that out and you get 0.497 amps. Oh, wait, sorry, that's not the answer, because actually you're not done. So you found I. Yay! Now you have to find the energy. So energy equals VIT. And so it's going to be 60 volts times that many amps times 60 seconds, and you get 1.79 kilojoules. And then you're done. I'm going to draw a happy person. And you have to watch, because you actually don't know when this video is going to end. And I might say, like, psych, I actually wrote all my equations upside down. So now you have to keep watching, and you're just gonna watch me draw this, like, happy person. And he's saying, yay. Oh, he's so cute. Oh. Okay, yeah, he's happy because he's done. Okay.